This video is also on section 2.5. It's going to deal with radical equations. The homework associated with this will be number 17b, the second part of 2.5. A radical equation is one that has a radical sign. And in order to solve these, here are the steps that you need to go through. Number 1, isolate the radical to one side of the equation. Remove the radical. Now remember to remove a square root. To undo a square root, you would square. To undo a cube, you would raise to the third power, etc. Now, then, solve the equation that you're left with. Some will be linear, some will be quadratic. And you must check these problems because sometimes you'll get what's called extraneous roots, extra roots. Alright, problem number 1. The first thing you need to do is to isolate the radical. So I'm going to move the 3 by itself. Now, this is a square root. To undo it, I'm going to square both sides of the equation. Now remember, if you square a square root, it undoes the signs and you're left with the radicand. Square the 3, you have a 9. Now this is a linear equation, so I'll move the 4 to the other side and I have x equals 5. Now when we check this, I'm going to replace in the original problem x with 5. This will not take long, but you do need to do this. And if you'll see, square root of 9 is 3. 3 minus 3 is 0. And if you come out with an identity, a number equals itself, then you're okay. So the answer is 5. In the second one, we have two radicals, but remember the problem said to isolate one of them. So I'm going to get square root of x plus 4 by itself. So I'm going to move this negative radical across and it will become a positive radical, just as any other term changes signs. Now to undo a square root, I'm going to square both sides. Now again, that's going to undo these signs. I'm left with x plus 1 equals 2x minus 5. That's linear. So I'm going to move all the variables to one side, all the constants to the other side, and then I'm going to solve for x, so I get x equals 6. Now to check that, I'm going to put a 6 in each x. I'm going to try to squeeze this in here. I think you can see it. So that's square root of 7 minus square root of 12 minus 5. Or square root of 7 minus 12 minus 5 is 7. And square root of 7 minus square root of 7 is equal to 0. And that's an identity. So my answer is x equals 6. Alright, problem number 3. Now remember, these just had to be a radical. This one is a cube root. Now to undo a cube root, you raise each side to the third power. So I have 11x minus 40 equals 5 times 5 times 5, or 125. I'm going to move the negative 40 over, it becomes positive, so that becomes 165. Divide by 11 and you get 15. Now to check that, I've got cube root of 11 times 15 minus 40 equals 5, or cube root of 165 minus 40 equals 5, or cube root of 125 equals 5, and the cube root of 125 is 5. So my answer will be x equals 15. Now, in problem number 4, don't get ahead of yourself. Remember, the first step says to isolate the radical. So I have cube root of 2x plus 1. Now that has to be by itself. If I move the 8 over, that becomes 3 minus 8. Or cube root of negative 5. To get rid of the cube root, I'm going to cube both sides of the equation. So 2x plus 1 equals, now notice I have 3 negatives. Negative times negative times negative, so that's negative. And 5 times 5 times 5 is 125. Let's move the 1 over. It becomes a negative. So 2x equals negative 126, or x equals negative 63. Now let's check this. I'm going to put in 2 times negative 63 plus 1 plus 8 equals 3. That'll be cube root of negative 126 plus 1, then plus 8 equals 3. Or cube root of negative 125 plus 8 equals 3. The cube root of a negative is negative. Cube root of 125 is 5. And negative 5 plus 8 is 3 equals 3. And that is an identity, so negative 63 is my answer. Now, of all these problems, perhaps this next type will be the most challenging. I have a radical on one side by itself, square root of 2 minus x, and then I have a binomial on the right side. Now, if you remember, I'm squaring both sides, not term by term, but both sides. If I square this square root, I have 2 minus x. But if you square a binomial, you remember that's x minus 2 times x minus 2 and 4, or use the mental method for doing this. Square the first term, that would be x squared. Multiply the first times the second, that's negative 2x, times 2, that's negative 4x. Square the last, that's plus 4. Sit that down in 4, or distribute, and you'll get that. Now that's a quadratic equation, so I'm going to move everything to one side. So this negative x comes over as positive x, so that becomes negative 3x. Positive 2 comes over as negative 2, so that'll be positive 2. Then I think that will factor into x minus 2 and x minus 1. And if you set both of those equal to 0, you get x equals 1 and x equals 2. Now, we need to check those. Let's check x equals 2 first. I'll put in 2 minus 2 equals 2 minus 2. I'm replacing the x with 2. That square root of 0 equals 0. Square root of 0 is 0. Now that one comes out to be an identity, so 2 evidently is an answer. Alright, let's check x equals 1. Now in place of x, that'll be 2 minus 1 equals 1 minus 2. Square root of 1 equals negative 1. Square root of 1 is 1. And 1 does not equal negative 1. Now this is what we call an extra root, and you will not see it in your answers. The only answer is x equals 2. Alright, now we're going to do another one just like that, just for practice. I have the radical by itself, so I'll square that side. Square the second side, and note that's a binomial. On the left, that leaves me with my radicand, 2x plus 5. And on the right, let's square this. Square the first term is x squared. Multiply x times negative 5, that's negative 5x, times 2 would be negative 10x. Square the last, that would be positive 25. Now I have a quadratic, so I'm going to move everything to one side. 2x comes over as negative 2x. 5 comes over as negative 5. Now if I factor, I'm going to get x times x and 10 times 2, with both of these being negative. So x minus 10 equals 0, x minus 2 equals 0. So I have two answers, x equals 10 and x equals 2. Now we'll have to check these. Let's check x equals 10 first. That would be 2 times 10 plus 5 equals 10 minus 5. Our square root of 20 plus 5 equals 5. Square root of 25 equals 5. Square root of 25 is 5 equals 5, and that checks. So 10 is a good answer. Alright, let's squeeze in right over here and check x equals 2. That'll be 2 times 2 plus 5 equals 2 minus 5. Or square root of 4 plus 5 equals negative 3. Square root of 9 equals negative 3. Square root of 9 is 3, which does not equal negative 3, so I have, again, an extra root. And the only one that you would mark as being correct in your homework would be 10.